Hello, welcome to another video. In this video, I'll be starting this paper of 99 problems for the Edexcel higher tier. These are marked as calculated questions, although there may be some questions from non-calculated papers as well. I thought this would be a good resource for you if you feel like you need a bit of extra exam revision on top of your other homework that you're doing. So maybe you can put this to the side, and if every now and again you feel like you want to do, say, 10 exam style questions, you can pull this out and have a go. So I wouldn't suggest doing this all in one sitting, but maybe keep it available if you ever need that bit of extra revision. So in this video, I'll be doing the first 20 questions of this paper. So let's go. Question 1 says the diagram shows a solid prism. On the grid, draw an accurate plan of the solid prism. So this is testing your knowledge of elevations. And there are three different views you can draw in elevations. That is the front view, the side view, and the plan view. Now front and side, they kind of tell you what they are in the name. The plan view is the only one that doesn't make it immediately obvious what you need to draw, but that's from above. So we need to draw this solid prism from above. And you kind of have to imagine this as a two-dimensional shape. So you need to be good at looking at a three-dimensional diagram and imagining it as a two-dimensional view. And that can be tricky sometimes, but if you look at these lengths, we need to draw this accurately. So we'll have to have a 2 centimeter width on this first rectangle and then a 4 centimeter length. So if I go down here to this grid, if I draw a 2 centimeter line here, that's going to be the top of that rectangle, then 4 centimeters down for the side, and finish off that rectangle, and that will be this first part of this solid prism. Then we can focus on this next part. Now this side here we're not going to see from above, right? Because this is a vertical plane or a vertical surface. So you're not going to see that from above. All you would see is this line here. So that's why we have that line in the middle. Then we can draw this rectangle. It has a 5 centimeter width and the same height as the other one. So all I need to do now is to join another rectangle to my first one with 5 centimeters across and the same 4 centimeters width or length, whatever you want to call those. Okay, so that should be good enough for my plan for my solid prism. And that was question 1 for 2 marks. Question 2 says ABD is a right angled triangle. All measurements are given in centimeters. C is the point on BD such that CD equals root 3 on 3. AD equals BD equals root 2 on 2. Work out the exact area in centimeters squared of the shaded region. Okay, so for these shaded region types of questions, usually what you want to do is to find the area of the larger shape and subtract the area of the smaller shape. That's generally a pretty reliable strategy for these find the area type questions. Okay, so what I want to do is to find the area of ABD, triangle ABD. How do we do that? Well, it's the base times the height. Now they tell us that AD equals BD. So BD is going to be root 2 on 2. So I've got the base and the height. Multiply those together, divide by 2, and I'll have the area. So let's go ahead and write down the area of triangle ABD. This is going to be, well, the base and the height are the same, so I could also write that as square root 2 on 2 squared, base times height, and then divide by 2 or multiply by a half, the same thing. Root 2 on 2 squared, well, root 2 times root 2 is just 2. 2 squared is 4. Multiply this by a half. And then, well, this is like a half times a half, which is a quarter. So the area of that larger triangle is a quarter. Then I want to find the area of this smaller triangle. So I have the base and the height of that as well. So let's go ahead and work that out. Area of triangle ACD equals root 2 on 2 times root 3 on 3, and then we need to half that, so multiply by a half. Now here you need to know how to multiply surds. So root 2 times root 3. For this operation, you can multiply the numbers inside the surds. So 2 times 3, and then leave the square root. So this will be the square root of 6 on 6 times a half, which we could simplify to the square root of 6 on 12. Okay, so I have the area of the larger triangle and the smaller triangle, and we need to subtract those. So the shaded region is going to be a quarter, take root 6 on 12. And I believe you could leave the answer as that, or you could simplify further. So you could combine these fractions by finding the lowest common denominator, which would be 12. So if I multiplied this one by 3, this would be 3 take root 6 on 12. But I believe that that answer is fine as well. So a quarter take root 6 on 12 for my final answer there. And that was a 3-mark question. Now it does say the exact area. So that's the reason why you want to leave it in that form. If you tried to work this out with a calculator, you'd get some decimal. You'd have to round that off, and that wouldn't be exact. So when it says exact area in these types of questions with surds, make sure you leave it in this form. And don't try to work it out with your calculator and get some irrational number where the decimals keep going. Okay, all right, on to question 3. Question 3 says, here is a trapezium. All measurements are shown in centimeters. Work out the area of the trapezium. Give your answer in centimeters squared in the form a root 5 plus b, where a and b are integers. Okay, so for this, we need to know the area of a trapezium formula. And that looks like this. So we have a plus b times the height, h, divided by 2. And a and b are the top and bottom sides of a trapezium. So for this trapezium here, root 5 would be a, root 5 plus 6 would be b. So firstly, insert all of those values into the formula. The height here is the perpendicular height, which they've given us. So this is going to be root 5 plus root 5 plus 6. And all of that is multiplied by the height, which is square root 5 take 2. And all of that is divided by 2. Okay, next, I might simplify this first bracket first before I expand them out. So root 5 plus root 5, that's like 2 lots of root 5. So we can write that as 2 root 5 plus 6 times root 5 take 2. And I might just multiply all this by half to save me having to write that large fraction line out. Okay, next, expand the bracket. So 2 root 5 times root 5. And I'll be using FOIL for this. So first, outers, inners, last. That's root 5 times root 5 is 5. So 2 times 5 would be 10. Outers, negative 2 times 2 root 5, negative 4 root 5. Inners, plus 6 root 5. And lasts, negative 12. And all of that is multiplied by a half. Next, keep simplifying. So 10 take 12 is negative 2. Negative 4 root 5 plus 6 lots of root 5. That's plus 2 root 5. And then divide all of that by 2. So we would get negative 1 plus root 5. And just to neaten it up a little bit, we might write root 5 take 1 instead. So you have that negative in the middle. And our final answer there is root 5 take 1 centimeter squared. That was a 3-mark question. Okay, next one. Question 4 says, write 5 take root 5 squared in the form a plus b root 5, where a and b are integers. Now you might notice some of these questions get a little repetitive. And that's going to happen if you put 99 questions all in one paper. But still, I think it's good practice. Repetition is never a bad thing. You can never be too good at a particular topic. Practice, practice, practice is always good. Okay, so expanding these brackets out, I would write them as 5 take root 5 times 5 take root 5. And then first outers, inners, lasts. 5 times 5 is 25. Then in the middle we'll have negative 5 root 5 take negative 5 root 5 would be negative 10 root 5. And then negative root 5 times negative root 5 would be plus 5. Then collect like terms. So we can't add this 10 root 5 to anything, but we can do 25 plus 5. And this would be 30 take 10 root 5. And that's as simple as we're going to get this. They've asked for it in the form a plus b root 5. So that's my final answer there for 2 marks. Okay, question 5. Expand 1 plus root 2 times 3 take root 2. Give your answer in the form a plus b root 2 where a and b are integers. Okay, again expanding brackets. 1 times 3 is 3. 1 times negative root 2 is negative root 2. Root 2 times 3 is 3 root 2. And 2 times negative root 2, that would be negative 2. 3 take 2 is 1, and negative root 2 plus 3 lots of root 2, that's going to be 2 lots of root 2. So final answer there, 1 plus 2 root 2. Okay, next one. Question 6, part A says express 5 root 27 in the form n root 3, where n is a positive integer. So for this one, you need to know how to simplify surds. So the square root of 27 can also be written as the square root of 9 times the square root of 3. Those two things are equivalent. And the square root of 9, you know, is 3. So this can be written as 3 root 3. So root 27 can be written as 3 root 3. Then if we looked at this expression, we would have 5 times 3 root 3, which can be written as 15 root 3. So that would be your final answer there. Part B says rationalize the denominator of 21 over root 3. When you're rationalizing a denominator, you want to multiply by that denominator over itself. So this is like multiplying by 1. It doesn't change the expression at all. But what happens is this denominator then becomes a whole number rather than a surd. So if we do this operation here, we'll get 21 root 3 over 3. Root 3 times root 3 is just 3. And then we can simplify further. We can do 21 divided by 3, which would be 7 root 3. So final answer there, 7 root 3. Question 7 says factorize y squared take 5y take 14. So for factorizing quadratics, I like to get to the point where you can do it all mentally. So there are methods where you do some working out on the page, but if you can get to the point where you can do it mostly in your head, then that's a good place to get to. If you're not at that point yet, that's fine. You can do things like write down the factors of 14 and then see if you can match them up to make to factorize this quadratic. But usually I would just look at the factors of 14, 2 and 7, and look at the coefficient of y and say, does 2 and 7 make 5? Yes, it does. And I'd have to have a negative 7 and a positive 2. Negative 7 plus 2 is negative 5, and then negative 7 times 2 is negative 14. So the final answer there would be y takes 7, y plus 2. Part B says expand and simplify 2 root 5 plus 1 times 3 root 5 take 1. So first, if I multiplied 2 root 5 by 3 root 5, well, you have to multiply the root 5 and the root 5. So that would be 5, and you have to multiply the integers as well. So 2 times 3 is 6. 6 times 5 is 30. So my first term there is actually going to be 30. 2 root 5 times negative 1 is negative 2 root 5 plus 3 root 5. 1 times negative 1 is negative 1. Then if we simplify this, negative 2 lots of root 5 plus 3 lots of root 5 is just 1 lot of root 5. 30 take 1 is 29. So overall, I'll have 29 plus root 5 here for a final answer. Part C says write 6 over root 12 in the form root n, where n is an integer. Okay, so for this one, firstly, we want to rationalize the denominator. So multiply this by root 12 on root 12, we would get 6 root 12 over 12. And then you can simplify this surd as well. So this could be written as 6 times root 4 times root 3 over 12. And now you might see that root 4 is 2. 2 times 6 is 12. So that would make 12 there. And then that 12 will cancel with the 12 on the bottom line. So all we're going to be left with is root 3. So the final answer there is root 3 for 2 marks. Question 8 says the perimeter of a square is the square root of 120 centimeters. Work out the area of the square. Give your answer in its simplest form. So perimeter, don't get confused with area. Perimeter is the length of the outside of the square. So I'll just draw a quick diagram just to kind of demonstrate how we're going to work this out. So all of those length added together equals the square root of 120. So if we called this x, for example, we would have 4 lots of x equals to the square root of 120. So 4 lots of that one side equals the perimeter. And then to work out the area, we're going to need the length of that side. So to get x by itself, divide by 4 on the right hand side. This would be square root 120 divided by 4. And then to get the, so we have the side length. To get the area, we need to do the side length squared. So x squared is going to be this squared, which would be, well, 120, the square root of 120 squared is 120. And then 4 squared is 16. But I just might write that as 4 times 4 because I know I want to cancel a 4 out anyways. 120 divided by 4, that's 30 on 4. And then 15 on 2. And then 15 divided by 2, that's like 7.5. So final answer there for the area, 7.5 centimeters squared. Okay, question 9 says the diagram shows a triangle DEF inside a rectangle ABCD. Show that the area of the triangle DEF is 8 centimeters squared. You must show all your working. Okay, so the triangle DEF is this one in here. And again, this is kind of like those shaded area questions. Find the shaded area. For this one, I'm going to find the area of the rectangle and each of these individual triangles, and then subtract the area of those triangles from the area of the rectangle. So to find the area of this first triangle here, I need the base. So I'm actually going to have to use Pythagoras' theorem to find this length. And for the other ones, I should be fine. So that's the only length I'm going to have to find here. So to find x squared is going to be the hypotenuse squared, take the other leg squared. So 2 root 10 squared, take 2 squared. This equals, well, 10 squared is 10, 2 squared is 4, so this would be 40, take 4, this would be 36. So then if x squared equals 36, x must equal 6. Okay, so I have this length up here. Now to find the area, base times height divided by 2. Well, if I'm dividing by 2, that kind of cancels out this length of 2 centimeters. So the area of this triangle DCF is just going to be 6. So let's do all of the areas over here. We're going to have to find quite a few areas. So the area of triangle DCF is 6. Next one, we could do this triangle EFB. Triangle EFB. 2 times 2 divided by 2 would just be 2. The next triangle, let's do ADE. The base of that, well, that would be this length of 6, take this little length here of 2. So this length would be 4. This one is 2 plus 2, which would be 4. So that area, ADE, is going to be 4 times 4, which is 16 divided by 2, which is 8. And then I also want the area of the entire rectangle, which would be the length times the width. So 6 times 4. So rectangle ABCD equals 6 times 4, which would be 24. Okay, so then to find the area of DEF, I want to do the area of the rectangle take all of these areas. So triangle DEF area, I should say, equals 24, take 6, take 2, take 8, which is 24 take 16. 24 take 16 is 8 centimeters squared. So it asks us to show that that area is 8 centimeters squared, and we've done that. Okay, so that was question 9 for 4 marks. So you might notice as this paper progresses that the questions will slowly get harder. So towards the end of the paper, they'll be the harder questions. At the beginning here, they're a little bit less challenging. All right, question 10. A equals root 8 plus 2, B equals root 8 take 2, T equals A squared take B squared. Work out the value of T, give your answer in the form C root 2, where C is an integer. So this is a substitution question. We're going to have to take these values, substitute them into this formula here to work out T. So T is going to be A squared root 8 plus 2 all squared, take B squared root 8 take 2 all squared, and then we're going to have to try to simplify this. A slight shortcut here: if you're expanding squared brackets, you can do the first term squared, which is 8, then 2 lots of the terms multiplied by each other. So 2 times root 8 is 2 root 8, and then add on another 2 root 8. So this is going to be plus 4 root 8, and then 2 squared is 4, and then we need to subtract this expanded. So this will be 8 take 4 root 8 plus 4, and then remember to expand that negative to all of the terms in those brackets. So don't leave those brackets out when you're doing that next line, because then you might make mistakes. So this is going to be 8 plus 4, which is 12 plus 4 root 8, and then subtract 8 plus 4 root 8, take 4. Okay, let's keep simplifying. 12, well, this 12 would cancel with these other constants over here. So negative 8 take 4 is negative 12. And then we'd just be left with 4 lots of root 8 plus 4 lots of root 8, which would equal 8 square root 8. Now it asks us to give the answer in the form C root 2. So the square root of 8 can be written as the square root of 4 times the square root of 2. So you notice those constants multiply to give 8. So this could be written as 2 root 2. So then this square root of 8 would be 2 root 2. Then we would have 8 times 2 root 2, which would be 16 root 2. So the final answer there is 16 root 2. Okay, next one. Question 11 says, rationalize the denominator of 10 over root 5. Give your answer in its simplest form. Okay, so another rationalizing the denominator. Should be pretty good at these by now. You need to multiply this by root 5 on root 5. 10 times root 5 is 10 root 5. 5 times root 5 is 5. And then that 10 divided by 5 would be 2. So final answer there is 2 root 5. Question 12. Another rationalizing the denominator. Multiply by root 5 over root 5. This almost becomes automatic after you do it enough. On the bottom line there, we would get 5. So this will be 15 root 5 on 5. And then that 15 divided by 5 is 3. So the final answer there is going to be 3 root 5. Part B says 1 plus root 3 squared can be written in the form a plus b root 3, where a and b are integers. Work out the value of a and the value of b. Okay, so we need to expand these brackets. 1 squared is 1. 2 lots of 1 times root 3 would be plus 2 root 3. And root 3 squared is just 3. So this could be written as 4 plus 2 root 3. So a is 4 and b is 2. Question 13 says, rationalize the denominator of this expression here. Give your answer in its simplest form. So you could simplify this top line first before you did the rationalizing, which is what I might do, but you could do it the other way around as well. So expand these brackets first. 6 times 6 is 36. 6 times root 5 plus 6 root 5. Take 6 root 5. And then take root 5 times root 5 is 5. And all of this is over square root 31. Then simplify. Well, this plus 6 root 5 take 6 root 5, they will cancel out. And then we'll just be left with 36 take 5, which is 31 on square root 31. Multiply that by square root of 31 over the square root of 31. We would get 31 root 31 over 31. Lots of 31s. They would cancel out, so we would just be left with the square root of 31 in its simplest form. And now 31 is a prime number, so I know that that is in simplest form. There's not going to be any factors that I can simplify. Okay, question 13. Question 14 says rationalize the denominator again. All right, this should be almost, you could do this in your sleep by now. 3 times root 7, 3 root 7. 7 times root 7 times root 7 is 7. So final answer there is going to be 3 root 7 on 7. Question 15, part A, rationalize the denominator of 5 on root 2. Again, multiply by root 2 on root 2. This equals 5 root 2 on 2. So final answer there, 5 root 2 on 2. Expand and simplify 2 plus root 3 squared, take 2, take root 3 squared. Okay, so we're going to have to expand each one first and then simplify. This will be 4 plus 4 root 3 plus 3. Take 4 root 3 plus 3. So negative root 3 multiplied by negative root 3 would be a positive 3. Then 4 plus 3 is 7 plus 4 root 3. Take 4 plus 4 root 3. Take 3. Remember to expand that negative to every term. And then let's see what we can cancel. Well, that 7 would cancel with these other constants. And then we'd just be left with 8 root 3 as our final answer. So 8 root 3 for 2 marks. Okay, question 16. Another rationalizing denominator. Multiplied by that surd on the bottom line. And then see if you can simplify anything further. So 12 root 3 divided by root 3 times root 3 is 3. Then you can do 12 divided by 3, which would be 4 root 3. Part B says work out the value of root 2 plus root 8 squared. Well, this would be 2 squared plus 2 lots of root 2 times root 8. Root 2 times root 8 is the same as the square root of 16. You can multiply those constants inside the square root. So this would be 2 times the square root of 16. And then that last term squared would be 8. So we get 10 plus 2 times the square root of 16. The square root of 16 is 4, so this would be 8. So final answer there would be 10 plus 8 would be 18. Question 17 says rationalize the denominator of this expression, give your answer in its simplest form. So again, I would expand those brackets out first. So this would be 16 multiplied by negative 4 root 2 plus 4 root 2. Take root 2 times root 2 is 2 all over root 7. Then simplify. So these middle terms here would cancel out, and then we'd be left with 16 take, which is 14 over root 7, and then rationalize, so multiply by root 7 on root 7, which equals, 14 root 7 over 7 would be 2 root 7. So final answer there, 2 root 7. Question 18 says root 3 on 5 plus 2 root 3 equals a root 3, where a is a fraction. Find the value of a. So for this one, I would probably combine those fractions. The lowest common denominator would be 5 times root 3. So I need to multiply this first fraction by root 3, which would be root 3 times root 3 would be 3. And all of this is going to be over 5 root 3. 3 plus 2 times 5 would be 10. And then we get 13 over 5 root 3. Now here is where you want to rationalize the denominator. So multiply by that surd there, root 3 on root 3. So even though you've got a constant there, you only need to multiply by that surd part of it. Then we get 13 root 3 over root 3 times root 3 is 3. 3 times 5 is 15. So we get 13 root 3 over 15. Therefore, that fraction is going to be 13 over 15. So that's what A equals. Okay, that was question 18. Question 19 says Emily buys a pack of 12 bottles of water. So not a surd question. Hooray! The pack costs £5.64. Emily sells all 12 bottles for 50p each. Work out Emily's percentage profit. Give your answer correct to 1 decimal place. So percentage profit, let's write down what that is. That is the profit divided by the cost. They give us the cost in the question, £5.64p. We need to work out the profit, and then we can work out percentage profit. So firstly, I would work out the total revenue, which is basically the total that she made from the sales. So 12 times 50p, 12 times 5 is 60. So she made £6 or 600 pence, however you want to write that. Therefore, her profit is going to be the difference between the total she made, take the cost. So £6 take £5.64, which is 36 pence. Now we have the profit and the cost. We can work out percentage profit, which is 36 over, and write this in pence, so they're in the same units, 36 over 564 pence. And for this one, I think we're going to use our calculators. As I said at the start, this is essentially a calculator paper, so please use your calculators where appropriate. So to get the percentage, we do 36 divided by 564 and then multiply that by 100. So this will be 6.38%, and it says to 1 decimal place, so this is going to be 6.4%. Because that third digit is an 8, we need to round up the 3 to a 4. So 6.4% is our final answer. I should say this should be multiplied by 100. So to get that percentage multiplied by 100, 6.4% for question 19. And question 20, part A says find the value of 2 to the power of negative 3. So when you have a negative index number, that's the same as writing 1 over that power. So this is 1 over 2 to the power of 3. 2 to the power of 3, 2 times 2 times 2 is 8. So this will be 1 over 8. Part B says 5 root 5 can be written in the form 5 to the power of k. Find the value of k. Alright, so another way of writing the square root of 5 is, well, this could be written as 5 times 5 to the power of a half. That's the same as the square root is to the power of a half. And then if you wanted to simplify this expression, remember when you're multiplying numbers with the same base number, you can add their index numbers. So this could be written as, 5 to the power of 1, essentially. If you have an integer and it doesn't have a power, it's the same as writing 5 to the power of 1. So we've got 1 plus a half, which is 5 to the power of 1.5, or 3 on 2, however you want to write that. So final answer there, value of k, 3 on 2. Part C says work out the value of the square root of 12, take the square root of 3, all squared. Okay, a couple ways you could do this question. You could expand the brackets out, or you could simplify the terms inside the brackets. So I'll do 2 ways of doing this question. So another way of writing the square root of 12 is to say this is the square root of 4 times the square root of 3, which could be written as 2 root 3. So this expression here could be written as 2 root 3, take root 3, all squared. 2 lots of root 3 take root 3 is 1 lot of root 3 squared, which is just 3. Okay, let's do the second way. So expanding those brackets out, we would get, well, let's write it out first. Square root 3 take root 3 times square root of 12, sorry, take root 3. Root 12 times root 12 is 12. Square root 12 times negative square root 3. You can multiply those numbers inside the square root. So 12 times 3 is negative square root 36. And then those inner terms will be the same. And then negative root 3 times negative root 3 is plus 3. 12 plus 3 is 15. Take 6. Square root of 36 is 6. And then we have another 6 there. So 15 take 6 take 6. 15 take 12 is 3. So just I would suggest doing it this way, but that was just if you did do it the other way, you'd still get the right answer. As it should be, as it always should be in mathematics. So final answer there, 3. And that was the first 20 questions of this paper. Stick around for part 2 if you want to go through the next set of questions. The whole paper isn't this repetitive, so it was the first, say, 20 questions that was mostly surds for some reason, but the rest of the questions, there's a good mix in there. So if you didn't like how repetitive those first set of questions was, don't worry, the whole paper is not like that. Okay, so I hope you found that useful. Please leave a like if you did, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.